Imagine a world without a single farm. Every berry, every grain, every bite of food had to be found, not grown. Then, around 12,000 years ago in the hills of the Fertile Crescent, someone noticed something strange. Where wild wheat had been scattered, new shoots appeared the next season. This observation would change everything. That first seed was a gamble. Early farmers saved the largest grains and replanted them. Over generations, wild wheat transformed into a plant with bigger seeds that stayed on the stalk. This was not magic, it was unconscious selection. Each harvest favored the traits humans wanted, slowly farming demanded a new way of life. Instead of moving with the seasons, people stayed put. They built permanent homes, stored grain in clay pots, and dug wells for water. Villages grew into towns. The first settlements like Jericho and Saddlehuruk housed hundreds, then thousands. For the first time, humans lived in community, but farming came at a cost. Skeletons from early farming villages show shorter stature, more cavities, and signs of hard labor. Diets narrowed to a few staple crops, causing nutritional deficiencies. Yet farming also created surpluses. For the first time, not everyone had to grow food. Some became potters, weavers, priests, and soldiers. Civilization trampled or flooded, it grew back thicker the next season. That observation, simple, accidental, profound, set humanity on a path that would change everything. This is the story of how ancient people invented agriculture, not in a laboratory, but through millennia of trial, error, and persistence. The first farmers didn't have a plan. They simply noticed that seeds dropped near their camps sprouted into new plants. Over generations, they began to encourage this process, clearing patches of land, scattering seeds, and returning to harvest. These early experiments were risky. A bad season meant starvation. But when it worked, the rewards were enormous, a reliable food source that could support larger communities. Slowly, villages grew around these fields, but agriculture came with a hidden cost. The first farmers worked harder than their hunter-gatherer ancestors. Their diets became less varied, and living in close quarters with animals and each other spread new diseases. Yet the die was cast. There was no relentless curiosity. The first domesticated crop was likely emmer wheat, followed by barley, peas, lentils, and flax. These plants were not tamed overnight. Early farmers selected seeds from plants that stayed on the stalk longer, a trait called non-shattering. Over generations, this unconscious selection transformed wild plants into domesticated crops that depended on humans for survival. But domestication was not a one-way street. It also changed the people. As farming provided a more reliable food supply, populations grew. Villages became towns, and with stored grain came a new problem: how to keep track of it all. This need for record-keeping would eventually lead to the first writing was not for poetry or laws. It was for accounting. Around 3400 BCE, in the city of Uruk in Mesopotamia, scribes used clay tokens to represent goods. Later, they pressed these tokens into clay envelopes and then began marking the envelopes with symbols. These symbols evolved into cuneiform, began as pictographs, simple pictures of objects. But over centuries, it became abstract. A picture of a star came to mean not just star, but also sky or God. This shift from concrete to abstract symbols was a cognitive revolution. It allowed humans to record not just things, but ideas. Selection transformed wild, brittle plants into reliable crops. By 8000 BCE, villages in the Levant were growing enough food to support permanent settlements. The agricultural revolution had begun. Alongside plants, ancient people domesticated animals. Goats and sheep were first, followed by pigs. Domestication provided a steady supply of meat, milk, and hides. Animals also served as labor, pulling plows and carrying goods. This new way of life spread slowly across the globe, reaching Europe by 6000 BCE and East Asia by 5000 BCE. With surplus food, not everyone needed to farm. Some became potters, weavers, or toolmakers. Specialization led to new technologies like the wheel, writing, and metallurgy. Villages grew into towns, and towns into cities. The first cities emerged in Mesopotamia around 4000 BCE, with thousands of residents living in organized societies. These early cities had governments, laws, and social classes. Kings ruled, priests performed rituals, and merchants traded goods across long distances. The agricultural revolution had not only changed what people ate, it had transformed the very structure of human society. Pigs, these animals provided meat, milk, wool, and labor. But domestication was a two-way street. Animals that tolerated human proximity reproduced more, passing on tameness. Over centuries, wild aurochs became docile cows and fierce boars turned into farm pigs. This partnership, humans a reliable source of food and materials, allowing settlements to grow into villages and eventually cities. But this success came with hidden costs. Living in close quarters with animals exposed people to new diseases. Measles, tuberculosis, and smallpox all jumped from domesticated animals to humans. The same closeness that fed civilization also made it sick. The Neolithic Revolution was not a single event, but a slow, uneven transformation that took thousands of years. Different communities adopted farming at different times, and some never did. Yet once agriculture took hold, it spread relentlessly. By 3000 BCE, farming had reached most of Europe, Asia, and Africa. The world would never return to a purely hunter-gatherer existence. This shift also reshaped human society. Surplus food allowed some people to specialize as potters, weavers, priests, and rulers. Social hierarchies emerged. Private property became important. Warfare increased as communities competed for land. The Neolithic Revolution gave us civilization, but it also gave us inequality, conflict, and hard labor. It was the best and worst thing to happen to humanity. Ancient farmers, a mobile food source and a powerful engine for plowing fields. Ancient farmers practiced selective breeding even though they had no concept of genetics. They saved seeds from the biggest, tastiest fruits and the most productive plants. They strongest animals to pull their plows and provide meat and milk. Over generations, these small choices added up to big changes. Crops grew larger, animals became more docile, and yields increased. This was evolution guided by human hands, long before, but selective breeding had limits. Farmers could only work with the variation already present in their crops and livestock. They couldn't create new traits from scratch. For that, they would need to understand the hidden mechanisms of heredity. That understanding would come from a quiet monastery. In the 1850s, an Austrian monk named Gregor Mendel began experimenting with pea plants in his monastery's garden. He carefully crossbred thousands of pea plants, tracking traits like seed shape, flower color, and plant height. He noticed that certain traits appeared in predictable ratios. Mendel's work revealed that heredity is governed by discrete units, which we now call genes. Strongest, most docile animals. Over hundreds of generations, these choices accumulated. Maize, for example, started as a wild grass called teosinte with tiny, hard kernels. By 2000 BCE, Mesoamerican farmers had transformed it into the large, soft ears we recognize today. This was not an accident. It was the result of deliberate selection, generation after generation, favoring the traits that made life easier. The same process transformed wolves into dogs, wild mustard into broccoli and cabbage, and bitter almonds into sweet ones. The dawn of agriculture, but it also set the stage for a new kind of power. Those who controlled the surplus, the extra grain, the stored harvests could feed others, and those who could feed others could command. The birth of hierarchy. For the first time, some people could live without farming. They became priests, scribes, soldiers, and kings. The surplus allowed specialization, and specialization allowed civilization. Genetic engineering, done by hand and eye. In arid regions like Mesopotamia and Egypt, rainfall was unreliable. So ancient engineers built irrigation systems. The Sumerians dug canals from the Tigris and Euphrates rivers as early as 6000 BCE. Egyptians used the Nile's annual flood to their advantage, creating basins to trap water and silt. The Egyptians used the Nile's annual flood to their advantage, creating basins to trap water and silt. This allowed them to grow wheat and barley in the desert. The shaduf, a counterweighted pole, helped lift water to higher fields. These innovations turned barren land into fertile farmland. The shaduf, a counterweighted pole, helped lift water to higher fields. These innovations turned barren land into fertile farmland, but irrigation required constant maintenance. Canals silted up, and fields could become waterlogged. Too much salt in the soil could ruin crops. Ancient farmers had to balance water carefully. Too much salt in the soil could ruin crops. Ancient farmers had to balance water carefully. They learned to let fields lie fallow and to flush salt out with extra water. These early experiments in water management laid the groundwork for modern irrigation. The lessons from Mesopotamia and Egypt still echo in dry regions today. The annual flood was a double-edged sword. It brought fresh water and silt, but it also required careful management. Farmers built dikes and sluices to channel water into basins, creating a system that demanded coordinated labor and oversight. This was the birth of organized society, a shift from scattered villages to structured communities. But irrigation had a hidden cost: salt buildup. Without modern drainage, water evaporated and left behind salts that accumulated in the soil. Over centuries, fields became saline and less productive. The Sumerians learned this lesson the hard way. Their wheat yields declined, and they were forced to switch to more. The salt problem was not just a local issue. It contributed to the decline of entire civilizations. In Mesopotamia, salinization reduced agricultural output, weakened the economy, and made societies more vulnerable to invasion and collapse. It was a slow-motion environmental disaster that unfolded over generations. The lesson of salt is still relevant today. Modern irrigation in places like California's Central Valley and the Indus Basin faces the same problem. Without proper drainage and salt management, fertile land turns into desert. The ancient Sumerians learned this the hard way, and we are for thousands of years, farmers tilled soil by hand with digging sticks. Then, around 4000 BCE in Mesopotamia, someone harnessed an ox to a wooden plow. This simple innovation multiplied a farmer's productivity. The plow broke up hard soil, buried weeds, and created furrows for planting seeds. It was the first great leap in agriculture, but the early plow had a problem. It only scratched the surface. In northern Europe, where soils were heavy and wet, the scratch plow was useless. So around the 8th century AD, farmers developed the heavy plow. It had a coulter to cut the soil, a plowshare to slice horizontally, and a mold board to turn the sod over. This created a deep, aerated seed. The heavy plow changed more than farming. It changed society. Because it required more animals and more labor, villages began to cooperate. Fields were divided into long strips, and families worked together. The heavy plow also made the soil so fertile that farmers could grow crops on the same land year after year. This led to permanent villages and the rise of the medieval manor system. But the heavy plow had a hidden cost. Turning the soil over exposed it to wind and rain. Over centuries, this led to erosion. In some places, topsoil washed away, leaving barren land. The plow that had fed millions also began to degrade the land. It was a lesson in unintended consequences, a reminder that every technology, no matter how beneficial, comes with a price. And created furrows for seeds. Later, the Romans added iron plowshares, and the Chinese developed the moldboard plow that turned soil over. The plow was the tractor of the ancient world, a force multiplier that fed growing empires. Ancient farmers noticed that planting the same crop year after year exhausted the soil. So they rotated crops, planting legumes like beans and peas that restored nitrogen. This simple practice doubled harvests and sustained civil. Irrigation was another breakthrough. The earliest farmers dug canals from rivers to their fields. In Mesopotamia, they built complex networks of ditches that watered wheat and barley. Without irrigation, the great cities of the Fertile Crescent would never have risen. But farming had a dark side. Storing grain attracted rats and insects. Surplus led to theft and warfare. And as populations grew, so did inequality. The first farmers also created the first tax collectors, the first armies, and the first slaves. The same crop year after year exhausted the soil. By the Roman era, writers like Columella recommended rotating legumes with grains because legumes restored nitrogen. The three-field system, planting one field with grain, one with legumes, and leaving one fallow, became standard in medieval Europe. Legumes like peas and beans host bacteria that convert atmospheric nitrogen into a form plants can use, enriching the soil for the next grain crop. This natural partnership allowed medieval farmers to maintain soil fertility without modern fertilizers, supporting population growth and the rise of towns. But even earlier, the Chinese practiced complex rotations and used green manure. These methods kept soils fertile for centuries, a sustainable cycle that modern industrial farming sometimes forgets. By the time of the great empires, Rome, Han China, Maya, agriculture was a sophisticated science. With irrigation canals, crop calendars, and selective breeding of plants and animals. These empires fed millions, and their agricultural knowledge spread along trade routes, influencing farming for generations to come. Even if it wasn't called that, farmers understood soil, seasons, water, and breeding through generations of observation. Their innovations, the plow, irrigation, crop rotation, domestication, are still the backbone of how we grow food today. The next time you bite into an ear of corn, remember that it didn't exist in the wild. It was created by ancient farmers who selected tiny mutations over thousands of years, transforming a grass called teosinte into the plump, sweet kernels we know. Domestication wasn't just about plants. Animals like wolves became dogs, wild aurochs became cattle, and jungle fowl became chickens. Each transformation required generations of selective breeding, often guided by accident as much as in. These ancient farmers didn't have laboratories or geneticists. They had patience, observation, and the simple act of saving the best seeds and breeding the best animals. That's how agriculture began, not with a bang, but with a careful hand. Or slice a tomato, remember. You are tasting the work of farmers who lived thousands of years ago, who had no books, no labs, but had something more powerful: curiosity and patience. They didn't have science. They had time, and they paid attention. Every time you bite into a sweet apple, you are connected to a chain of selection that began when a curious human first noticed a tree with slightly larger fruit and decided to take a branch and plant it near their home. That simple act, taking a cutting and replanting it, was the first genetic modification. It wasn't done in a lab. It was done with bare hands under the sun by someone who noticed a difference and acted on it. And that is the story of every crop you eat. Not a story of sudden invention, but of slow, patient transformation, one generation passing its best seeds to the next, until the wild became the familiar.